James McGinn. So much of what gets accepted in natural science is based on what's simple, easy to digest, and easier to teach. Take climatology's theory of catastrophic global warming. It's the poster child for scientific oversimplification. Misinformation is rampant, and it all starts with a fundamental misunderstanding of H2O. It all began with Linus Pauling about 70 years ago when he made a huge conceptual mistake, and the scientific community blindly followed suit. I call this Pauling's blunder. Professor Dave. Water is liquid at certain temperatures, solid below that, and gas above it. Other substances follow the same principle. H2O bonds are polar because of the large electronegativity difference between oxygen and hydrogen. It's basic chemistry. Polarity has nothing to do with the mass of an atom. There's no grand paradigm or taboo here. It's just you misunderstanding high school level chemistry. Learn about molecular geometry, chemical bonds, and intermolecular forces. That would clear up your confusion. James McGinn. I don't agree with everything you're saying about water. A lot of it is urban myth, not empirical science. It's just what's currently accepted. Professor Dave. There's no paradigm. James McGinn. There's always a paradigm. Professor Dave. Watch my content. It'll clear up all your confusion. James McGinn. As a scientist, I can't dismiss details and contradictions the way you do. Professor Dave. You're not an expert on water. Go get a degree in chemistry. Professor Dave. Water is simple. James McGinn. On its own, yes. But when it comes together, it's incredibly complex. Professor Dave. Only someone who doesn't understand chemistry would claim it's all wrong. You clearly don't get molecular polarity, molecular orbitals, or colligative properties because you haven't studied them. James McGinn. Honestly, you don't even seem to know what you're disputing. Professor Dave. What are these so-called anomalies? Explain them clearly. James McGinn. Without specific questions, I can't help you. Professor Dave. What I learned isn't vague or up for debate, it's solid chemistry. James McGinn. It's a model meant to appeal to the masses, glossing over critical details like H2O anomalies. You're stuck in generalities while I'm talking about cutting-edge science. You rely on consensus, not investigation. Professor Dave. Water has a high specific heat due to hydrogen bonding, and its low viscosity is because it's a small molecule. You're making up discrepancies that don't exist. How can the dipole change without altering the molecule itself? You already said the structure doesn't change. The contradictions are all in your explanation. James McGinn. Yes, the structure doesn't change, but that's beside the point. In my model, it's the stretching of the electron cloud that triggers polarity. Under certain conditions, this stretching reverses, a phenomenon I call incidental symmetry. That's why water molecules, despite their polarity, have low viscosity. They neutralize each other's polarity by reversing the stretching of their electron clouds when close together. That's what you're actually observing when you notice low viscosity. Professor Dave. How can water molecules just turn off their polarity? Explain the mechanism. James McGinn. Like I said, it's all about hydrogen bonding. These bonds allow water molecules to relieve the stretching of their electron clouds, which is the root cause of polarity. This reversal neutralizes their polarity when they cluster, which also contributes to water's high heat capacity. Without this mechanism, water's viscosity would be through the roof. Professor Dave. You still haven't explained how an electron cloud stretches or reverses. That's not a real concept in chemistry. James McGinn. Oh, but it is. Polarity is all about the stretching of the electron cloud. An atom becomes polar when its electron cloud gets pulled off center from the nucleus. That's what gives rise to a dipole moment. In water, hydrogen bonds are critical because they reverse this distortion, neutralizing the molecule's polarity when they cluster. That's why water can have low viscosity despite being highly polar. Your fixed idea of polarity is way too simplistic to explain water's more complex behaviors. Professor Dave. You're just throwing around new terms like electron cloud stretching, and incidental symmetry. If these were legitimate concepts, they'd be in standard chemistry books, but they're not. James McGinn. Just because they're new doesn't make them less valid. Science has always been about challenging old models. The traditional understanding of water misses these complexities, which is why it fails to explain its anomalies. My model, however, does. Professor Dave. I'm asking for evidence, not made-up terms. Show me the actual anomalies and how they're connected to this idea of variable polarity. James McGinn. The anomalies are well documented. Take water's high heat capacity and low viscosity. Conventional models don't fully explain these properties. But through my mechanism, where water molecules neutralize each other's polarity, it all makes sense.